Welcome to week 4 of distance learning. We're going to be adding and subtracting rational expressions. Buckle up, work hard on this. Make sure that you're not sending a picture of your notes to your friends. They need to watch this video and take their own notes so they understand the process. So make sure that you're keeping it honest and not sending them any pictures of completed work, please. This particular slide you don't have to write down. I just want to have a quick conversation with you about canceling before we dive into the new topic. Okay, so before we get started in this process, I want to talk to you a little bit about canceling like factors. You can only cancel a like factor in the numerator and in the denominator. If the like factors are both in the numerator or both in the denominator, they don't cancel. Also, the problem has to be entirely multiplication before we can cancel. So this first example I've written on the paper, these 3's cannot cancel yet. What we need to do first is we need to simplify that numerator by making it 3 plus 30. And then we need to combine like terms. And then we can do our reducing. 3 goes into 33 11 times. If we cancel initially, all you're left with is like 1 plus 30, and that's not equivalent to 11. You can't cancel until you make the problem entirely multiplication. Take a look at this bottom one. I might be tempted to cancel out the x plus 3's, but the x plus 3 is not a factor because the entire numerator is not multiplication. It's only a factor once we've turned it into a multiplication problem. So let's first distribute that x through. Once we've distributed the x through, I'm going to combine like terms. And then I'm going to factor that numerator using product sum method. Then, now that I've made the problem entirely multiplication, now I can cancel out. So it's only a factor if it's multiplied together with other factors. So as this is currently written, x plus 3 is a factor of the numerator because it's multiplied times x minus 5. And that first part of the first problem that we started with, or the first part of the problem, the x plus 3 is not a factor since it's not multiplied times everything in the numerator. Okay, so now this is where I want you to start writing down the notes. So I'll give you a second to copy down this example. When we add or subtract rational expressions, we need a common denominator. So the first thing we're going to do is we're going to factor all denominators. Just the denominator. If the numerator can be factored, don't do it. So that's a difference from multiplying and dividing rational expressions. We're only factoring the denominators in these problems. So doing that, we're going to get x minus 2, x plus 2, because that's a difference of 2 squares. Okay, so as you know, when you add or subtract fractions, you need to get a common denominator. So to get a common denominator, we're going to multiply by the missing factor. So if you compare these denominators, you can see that the first denominator has 2 factors, and the second denominator only has 1 factor. So that second denominator is missing a factor of x plus 2. So we're going to multiply by any missing factors in the denominator. Now to show that this is all multiplication, make sure you put parentheses around that x minus 2. So we're going to multiply by any missing factors in the numerator and denominator. In the numerator and in the denominator. So since that second fraction was missing the factor of x plus 2, we multiply in the numerator and the denominator. The reason we do that is multiplying by something over itself is the same as multiplying by 1. And that doesn't change the value. If I were to multiply something by 5 over 5, that's the same as multiplying by 1. Multiplying by 1 does not change the value of an expression. Okay, so now that we have a common denominator, we can combine this into a single fraction. So everything that's in the numerator gets written together. The denominator only happens once. So that would be similar to adding two fractions. If I were adding 1/2 plus, say, 3/2, I would only write the denominator once, and then I would add what's in the numerator. 1 plus 3 would give me 4. So when you combine this together, you're only writing the denominator once, and you're going to combine everything that's written in the numerators. So what we're doing next is we're writing as a single fraction, or write as a single rational expression. Okay, so let's go ahead and keep going. So in the numerator, what I'm going to do now is I'm going to distribute that x through. Because like I talked about in the previous slide, I might be tempted to cancel the x plus 2's, but I can't cancel those yet because I have some addition happening here in the numerator. So I have to make sure x plus 2 is a factor before I can cancel it out. I can't cancel the x plus 2 until I make an entirely a multiplication problem. So what we're going to do is we're going to distribute that x through in the numerator, and we're going to get x squared plus 2x. Okay, so distribute the x through. Distribute x. Okay, so now in the numerator, let's go ahead and just move this 8 to the back so we can see what we have a little bit more easily to factor. So I'm just going to move that 8 to the back so it's in standard form. Okay, so our next step is to factor, and then we can do any canceling. So notice when we do this problem, we cancel at the very, very end of the problem. So what do we get here? We're going to get x plus 4, x minus 2. The denominator, again, remains unchanged. So then these x minus 2's can cancel since I made the entire problem a multiplication problem, and my final answer is x plus 4 over x plus 2. Okay, so this process is a lot more complicated than multiplying or dividing. So make sure you're paying very, very close attention to this video, and you can refer back to this video as much as you want doing your homework. One word of caution. When you do these problems, do not cancel out until the very end. What some people are tempted to do is they're tempted at this point to cancel those x plus 2's. No. You put them there for a reason. They do not cancel. Something else that people are tempted to do is they're tempted to cancel these x plus 2's. You can't cancel yet because it's still an addition problem. You can only cancel at the very last step when we've rewritten it in this form. Everything is factored and it's a multiplication problem. Then we can cancel. Okay, let's try this one. Okay, so this guy, we are going to do some factoring again. So we are going to rewrite the problem and factor any denominators. So this is the only denominator that can be factored. I'm factoring out a greatest common factor of x. Okay, so now that we have that denominator factored, we're going to multiply by what's missing to get common denominators. So if you look at the second expression, it's missing an x. The first denominator has an x and an x minus 8. The second one is missing an x. So I'm going to multiply by the numerator and denominator of that second expression by x. So again, to show that I'm multiplying, I'm going to make sure and put parentheses around that x minus 8. Okay, now that we have a common denominator, we can combine these into a single expression. Everything in the numerator gets written, and we only write the denominator once. I can't cancel these x's yet. You might be tempted, it's very common, you might be tempted to cancel here, but again, it's not entirely a multiplication problem in the numerator, so I need to first combine some like terms and do some factoring. So in the numerator, we have x squared minus 64. That you'll recognize as a difference of two squares. So we can factor out, or we can factor the numerator as x minus 8 times the quantity x plus 8. Once we do that, you can see that the x minus 8s are going to cancel. So we're left with x plus 8 over x. Now, can these x's cancel in the final answer? No, because I don't have multiplication anymore. If the x and the 8 were multiplied in the numerator, then I could cancel, but since they're added, I cannot cancel. Okay, please keep watching. The last two problems are subtraction, and those are a little bit different. So again, this is a complicated topic. That's why we have to do so many examples. Feel free to watch this and rewatch it as needed. Again, our first step is to factor each denominator. Some kids playing out there. X plus 1 times the quantity x plus 3. Here we have x minus 3 and x plus 1. Okay, so that first fraction, well, x plus 3 and x minus 3 are not the same factors. So this first fraction is missing a factor of x minus 3. So we have to multiply so that it has the x minus 3 factor. Our second fraction is missing a factor of x plus 3. So we multiply by x plus 3 in the numerator and denominator. Okay, now that we have a common denominator, I make it one fraction. The denominator only gets written once, but then I write everything in the numerator. Can I cancel now? No, 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 no. The numerator is not entirely multiplication yet because I have that subtraction sign in the middle. I have work to do before I can do any canceling. So what we're going to do is we're going to first distribute, and then we're going to combine some like terms. So we're going to distribute the x here, and then we're distributing the negative 2 here. So we get x squared minus 3x minus 2x minus 6. And then we rewrite the denominator. The denominator does not change for a long time in these problems. Again, the denominator doesn't change. I'm going to combine like terms in the numerator. Rewriting the denominator again and again. Okay, finally, the most fun part, the last two steps are factoring and canceling. So factoring the numerator, let's see, x minus 6, x plus 1. Now everything is factored. There's no plus or minus signs between the factors. So we have a bunch of factors that are multiplied together. So now I can cancel the x plus 1s out. And everything that remains, I write it as a single fraction. Woo! Man, these aren't for the faint of heart, but I'm so glad I have some math warriors out there. You got this. One more, math stars. Let's do it. All right. Factor just the denominators. I don't care if you're given a problem that has a numerator that looks like it can be factored. Don't do it. Only factor the denominators. Okay, so we're going to multiply each factor by what's missing, each rational expression by what's missing in both the numerator and the denominator. So this first one is missing a factor of x plus 1. The second fraction has it, the first fraction's missing it. Again, use parentheses to show that you're multiplying. Let's look at the second denominator. It's missing a factor of 2. So I'm multiplying by 2 in the numerator and denominator. Again, parentheses are your friends. They look like a big hug, and they show us that we're using multiplication. Write everything as a single fraction. Only write the denominator once. Okay, in the numerator, we can combine 2 steps at once. Can't cancel yet. Remember, that's the very last step we do. But if I want to save myself a little bit of writing, I can go ahead and do my distributing before I write it down in the new fraction. So I can distribute that x, and I get x squared plus x. Okay, now this is tricky, but I know you can follow this. See this minus sign here? That needs to be distributed also. So I'm going to distribute the 2 to both terms, but then the signs are going to change on both since I have that minus sign in front of that step. So I'm going to get 2x and then 30. But because that negative's there, I distribute it and both terms become minus. Let's go back to green. Go green. Go white. Go green. Go white. Combining like terms. Woo! Is this hard work? Yeah, dog. Can you do it? Sure can. It's good for you. Work hard. Okay, last 2 amazing steps. Factor and cancel. Factor the numerator. We get x minus 6, x plus 5. These cancel. We're left with x minus 6, 2, and then x plus 1. Woo! Man, these are tough problems, so rewatch these as much as you need. Again, while you're working on the problems, feel free to watch this. I will also link to some Khan Academy video. Feel free to watch those as needed also. All right, math stars, work hard, keep it honest, and message me or join me in office hours if you need help.